So we're now going to look at adding and subtracting algebraic fractions. So algebraic fractions can be added in the same way as numerical fractions. In other words, we need to make a common denominator and then make equivalent fractions. And we can do this by scaling our fractions, or we can use the kiss and smile method. So our first one, we're going to add simple algebraic fractions. We've got 4 over x plus 5 over y. Now the first thing we want to do is we want to work out what our common denominator is. And we're going to multiply the x and the y together to give us a common denominator of xy. Now we want to convert the first fraction, and we do that by taking the 4 and multiplying it by the y. And we get 4y. And then we're going to convert the second fraction, and we do that by taking the 5 and multiplying it by the x, and that gives us 5x. We then need to just double check whether or not there are any common factors. We can simplify this any further, but we can't, so the final answer to 4 over x plus 5 over y is 4y plus 5x all over xy. What happens if the fractions have linear denominators? So you can see here we've got 2a over a plus 5, and we want to find the difference of 5 over a plus 3. So remember, the divide by line means that there are brackets around the numerator and brackets around the denominator. So when we're finding our common denominator, we're multiplying our a plus 5 by our a plus 3. And so our common denominator is a plus 5 upon a plus 3. We want to convert our first fraction, so we're going to do 2a multiplied by a plus 3. And we're going to convert our second fraction, and we're going to have negative 5 multiplied by a plus 5. So the next thing we're going to do is we're going to expand our brackets. So we've got 2a times a gives us 2a squared plus 6a. And we're going to take away 5a minus 25, and we're going to leave our common denominator as a plus 5 upon a plus 3. And we don't need to expand that unless we're asked to give it in a certain format. And then we're going to collect our like terms. So you can see there we've got a plus 6a and a minus 5a that we can collect together to give us an a. So our final answer is going to be 2a squared plus a minus 25 all over a plus 5 upon a plus 3. Now sometimes our denominators will have a common factor. And so using the kiss and smile method is going to overcomplicate things. So we want to add these fractions, 2a over a plus 1 a minus 2 plus 5 over a upon a minus 2. So we're going to look for common factors. We've got an a plus 1, an a minus 2 and an a. We're not going to repeat that a minus 2 that's repeated on the second fraction. So our common denominator is going to be, and we'll write it in order, a upon a plus 1 upon a minus 2. Now to convert the first fraction, we're going to multiply it by the extra fraction we've got in our denominator, which is the a. So we're going to do 2a multiplied by a. And to convert the second fraction, we're going to multiply the 5 by the extra a plus 1 that's on the common denominator. Now we need to expand our brackets so that we can simplify. So we're going to end up with 2a squared plus 5a plus 5 all over a upon a plus 1 upon a minus 2. And then we check to see if we can simplify it any further, and in this case we can't. So if our fractions have quadratic denominators, it might be necessary to factorise before we can find what the common denominator is. So in our final example, we want to add these fractions. We've got 3 over x squared minus 4x plus 3 plus 2 over x squared minus 9. And you can see we've got a trinomial on the bottom of our first fraction and a difference of 2 squares on the bottom of our second. So we're going to factorise our denominators first. So we've got 3 over, and our factorising of x squared minus 4x plus 3 is going to give us x minus 3 upon x minus 1. And then we're going to add on 2 over our difference of 2 squares, which is going to be x minus 3 upon x plus 3. Now we're going to work out what our common denominator is going to be by looking for any non-repeated brackets. So we've got an x minus 3, an x minus 1, and an x plus 3. So we'll put them as our common denominator, which is x minus 1 upon x minus 3 upon x plus 3. Remember, we don't include that repeated bracket. Then, in order to convert the first fraction, we need to multiply that by the extra bracket, which is the x plus 3 bracket. So it's 3 upon x plus 3. And we're going to convert the second fraction by multiplying it by the x minus 1 bracket. So it's 2 upon x minus 1. Now we're going to expand those brackets. So we're going to get 3x plus 9 plus 2x minus 2. And that's all over x minus 1 upon x minus 3 upon x plus 3. And then we're going to look to simplify, collecting our like terms. So our x terms are 3x and plus 2x. And our constant terms are plus 9 and take away 2. So our final answer is going to be 3x plus 2x gives us 5x plus 7 all over x take away 1 upon x minus 3 upon x plus 3.